Hi everybody. So I know the first Tech Live went really quick because we spent a lot of time talking about how the class is laid out. So I'm making this other video to go over the rest of the problems, and I'll make sure to show you how to put things in the calculator too, because I really want to encourage you to do that so this class is not overwhelming. So let's talk about adding and subtracting fractions. And big deal here is that you have to have the same denominator before you try to add things together. So I will show you how to do it, but I'll also show you how to use it with technology. So the first one says 3 over 8 plus 1 over 4. So what I need to do is have the same number on both of the fractions, and the same number, I mean the bottom number. So what you're looking for is a number that 8 and 4 have in common. Well, it happens to be that 4 goes into 8, so I can use 8 as my common denominator. And what I want to think about is how would I turn the 4 into an 8? Well, that would be by multiplying by 2. But if I multiply the bottom of the fraction by 2, I also multiply the top by 2. Here's the thought. 2 over 2 is 1, and if I multiply 1/4 times 1, I still have 1/4. So what I have here is 3 over 8 plus 2 times 1 is 2, 2 times 4 is 8. Now that the denominators are the same, I can add the fractions. 3 plus 2 is 5 over 8. So when you have that common denominator, a over b plus c over b, you just add the numerators a plus c over b. It takes a while to get used to. That isn't something we kind of do in our heads all the time, but it is something that I want you to see. Even though you have calculators, there are times that we don't have numbers, we have variables. So the idea here of the bottoms having to be the same is an important concept for you to know. So I'm going to work them all out by hand, and then I'll show you the same thing with technology, and I'll do two different calculators. So the next one says 5 over 6 minus 3 over 10. So again, I'm thinking about this 6 and this 10, and I'm thinking like, is there some kind of number that they have in common? Maybe the easiest thing to do is say 6 times 10 is 60. Like that definitely works if you're looking for what's easy. And you can kind of just multiply it by the opposite number. When you do that, so let's say I have 5 over 6 and I want to multiply by 10, you would multiply the bottom by 10 and the top by 10. So when I look at the 3 over 10, I'm multiplying by 6 on the top and the bottom. So whatever you do, you're just being consistent. 10 over 10 is 1, 6 over 6 is 1, and that way what I'll end up with is 5 times 10, that's 50, over 60. 3 times 6 is 18 over 60. So that works. I got to this common denominator of 60, and then you subtract. 50 minus 18 is 32 over 60. Now what I want you to do is look at it and say, is that the best answer I could give? Could I make this any simpler? So I could think, well, 32 and 60 are even, so I could divide by 2. So 32 over 2 is 16. 60 over 2 is 30. So that got a little smaller. But then I think, look, they're still even, so let's do that again. 16 over 2 is 8. 30 divided by 2 is 15, and see how I got to 8 over 15. So it's okay to do multiple steps. Sometimes those steps save you time in the long run because then you don't mess it up and you don't have to start over. Now, 60 isn't the only number I could use. It was kind of like the first fast one I thought about. So let me show you a different way. Let's say I look at 6 and I say 6 is 3 times 2. And I look at 10 and I see it's 2 times 5. So there's this 2 in common. So let's just write down the 2. And then I have a 3, and then I have a 5. 2 times 3 times 5, that's 30. So 30 could also be a denominator I could use. 6 goes into 30, 10 goes into 30. So I think about 6 goes into 30 5 times. So I would need to multiply the numerator and denominator by 5 if I want to turn the denominator into 30. And then with the 3 over 10, well, I think about 10 goes into 30 3 times, so I multiply the top and bottom by 3. So now when I multiply, 5 times 5 is 25 over 30. 3 times 3 is 9. 10 times 3 is 30. So when I subtract 25 minus 9, I get 16 over 30. Just like I did earlier, I think about, could I make that better? Well, 16 divided by 2 is 8. 30 divided by 2 is 15. So I get that same answer. What I like here is that you have choices, so you do the choice that works for you. Let's try one more. I have 2 over 3 plus 7 over 8. 3 and 8 don't have anything in common. There's not a number that goes into 3 that also goes into 8, so the only thing I can do here is 3 times 8 is 24. So to get the denominator of 24, the 2 over 3 is going to multiply by 8 over 8, and the 7 over 8 is going to multiply by 3 over 3. So 8 times 2 is 16 over 24. 7 times 3 is 21 over 24. Then when I add that together, 16 and 21, that gives me 37 over 24. Now this number, different than our previous two, the numerator 37 is bigger than the denominator 24. So sometimes they'll talk about mixed numbers or improper fractions, and I'll be covering that. So just kind of watch the directions to say what it says you have to do, because there could be a little difference in how you enter the answer. Let's do each of these using a calculator, and I'll kind of come back and forth so we can see what happens. So I told you in class that I like this calculator called Desmos. You just Google Desmos and it'll come up. And what I can do is just type in 3 divided by 8 and then say plus 1 divided by 4. It always starts as a decimal as your answer, but then you click this little button and it changes it to a fraction. So you look for this little box over box. Let's do the next one, 5 divided by 6. I push the arrow over to get out of the denominator, and then I say minus 3 divided by 10. Again, it gives me a decimal. I hit this double box. It comes back to a fraction. There's 8 over 15. The last one we had was 2 divided by 3, 7 divided by 8. Again, decimal. I hit it to a fraction. There's our 37 over 24. Now, if you have a handheld calculator you like, that's perfectly okay. You can go to YouTube and it will probably tell you. You just put in your calculator and the fraction it is, and it should tell you how to go back and forth. I also have this other calculator called the TI-84. So I just want to show you this to say that there are regular calculators that aren't online that will also do fractions. So watch, if I do 3 divided by 8, and then I say plus 1 divided by 4, it gives me a decimal. And this calculator, I hit math, it says fraction, so I enter that and it changes it back. So let's try kind of putting that together with other things we've learned. So this takes fractions in order of operation. So I have negative 5 over 27 plus 4 times negative 1 over 3 squared. Order of operation says you do parentheses exponent. So the exponent is what I start with. So I have this negative 5 over 27 plus 4 times negative 1/3 squared means negative 1/3 times negative 1/3. So I have negative 5 over 27 plus 4. Negative 1 times negative 1 is 1. 3 times 3 is 9. Now I want to do this multiplication. So I'm going to turn the 4 into 4 over 1. I have negative 5 over 27 plus 4 times 1 is 4. 1 times 9 is 9. I need a common denominator. If you think of 27, 27 is 3 times 9. So what I need to do is multiply by 3 over 3. That way I get a 27 for the 4 over 9. So I have negative 5 over 27 plus 4 times 3 is 12. 9 times 3 is 27. Negative 5 and 12 is 7 over 27. That cannot be reduced. Let's say we want to use the calculator to help us. You would do parentheses, negative 5 divided by 27. Get out of the denominator, close the parenthesis, and I just use my arrow to do that, plus 4. To do times, I hit the asterisk that's over the 8, or you can open up the keyboard and there's a multiplication sign. And then I do parentheses, negative 1 divided by 3, get out of the denominator, close the parenthesis, square it. So to square, I hit the caret, so there's this thing over the 6, and I hit a 2, or you can see there's an a squared in the keyboard. All right, comes out with this decimal. I make it go back to a fraction by clicking this little button. So I don't want you to be overwhelmed with all the operations. Technology is your friend. So let's go back to those things called improper fractions. So improper fractions happens when the numerator is greater than or equal to the denominator. So like 5 over 4, 17 over 3, 9 over 6. So anytime the top greater than or equal to the bottom means we could kind of write this a little different. So what we'll turn it into is like a mixed number or a mixed fraction, which means you'll have an integer part and also a fraction part, like 1 2/3 or 3 1/2, 8 2/5. We talk about numbers like this all the time. Think about maybe when you're cooking, right? You might use 1 2/3 cups of flour in something, or 3 1/2 cups of sugar. I don't know what you make that, but sugar, but you get what I'm saying. Like we have times where we only use part. So when you're doing this in Mobius, to tell it 1 2/3, you need to put a plus sign in between, because if not, it would kind of read it as 12 over 3 instead of 1 2/3. So the only thing we can do to separate it is to put that plus sign in there. That way it separates the 1 from the 2/3. So it's a good thing to have to do. So when we add, subtract, multiply, or divide, anything that has a mixed number though, we really need to write it as an improper fraction, which is why sometimes we don't use a lot of mixed numbers, is because they're not easy to work with. So how we change things back and forth is you have to multiply the denominator times the whole number and add it to what you already had in the numerator. I kind of think of it like a circle. So if I have 5 1/3, I'm going to multiply 3 times 5. And then I'm going to add 1, and I leave it over the denominator. So 3 times 5 is 15, plus 1 over 3 is 16 over 3. Really what is happening here is it's saying like we want a common denominator. So I would go 3 over 3, and then I have this 1/3. If I do 5 over 1, right, 3 times 5 is 15, 3 times 1 is 3, and then I have my 1/3, this is 16 over 3. So we're just changing a number from a mixed number to this improper fraction, and here's how we're doing it. But I like you to see we're just going back to common denominators. So same thing happens here. I have 7 times 6, and then I add 5, and I keep over 6. So 7 times 6 is 42. I add 5 over 6. 42 plus 5 is 47, and this is over 6. So let's try adding these two mixed numbers. I have 6 1/2, and I have 3 and 2 over 9. First thing I need to do is change them to improper fractions. So 6 times 2 is 12 plus 1 over 2. 3 times 9 is 27 plus 2 over 9. So I have 13 over 2, and I have 29 over 9. 9 and 2 don't have any common factors, so the best I can do is do 2 times 9 is 18. So the 2 needs to be multiplied by 9, so I do 9 over 9. The 9 needs to multiply by 2, I do 2 over 2. 13 times 9 is 117 over 18. 29 times 2 is 58 over 18. So I'm going to add 117 plus 58. This gives me 175 over 18. Now this can't be reduced anymore, but you do have to watch for if Mobius asks you to give this as a mixed number or an improper fraction. If it says improper fraction, you're good right now. But if it asks you for a mixed number, then we're going to have to figure out what does this look like. So you need to do 175 divided by 18. So I do 175 over 18, and just say in a regular calculator, and it says 9.72, something like that. So you can see the 9 part. That's important. So I'm going to look at what 9 times 18 is. 9 times 18 is 162. So 162 of this 175 is already used up in the 9. But the rest of it, 175 minus 162, which is 13, is left over. So that says this number is the same as 9 plus 13 over 18. This is how we would write it, 9 plus 13 over 18 in Mobius. We could try that with subtraction. So I have 7 1/8 minus 4 and 5 over 12. If I change these to improper fractions, 7 times 8 is 56 plus 1 over 8 minus 4 times 12 is 48 plus 5 over 12. So I have 57 over 8, and I have 53 over 12. So let's write down that we think of 8, hopefully, as 4 times 2, and I think of 12 as being 4 times 3. So what you're trying to do when you find this denominator is represent everything. So I need to represent the 4, we write it down. I need to represent 2, let's write it down, and then I need 3. So 4 times 2 times 3 is 24, and that way I keep the number small. So 8, I would multiply 3 over 3 to get 24. With the 12, I would multiply 2 over 2 so that I get my 24. I'm still going to use my calculator though, because 3 times 57 I don't want to do in my head. It gives me 171 over 24. 53 times 2 is 106 over 24. 171 minus 106 gives me 65 over 24. I'll show you a different way to do this. I could say 24 goes into 65, and let's say it would go 2 times. Luckily, 24 is a number we know, 24, 48, 72, like thanks hours in a day. 2 times 24, there's 48. And then when I subtract, I get 17. What this says to me is that this 65 is a whole number 2, and I would have 17 over 24 left over. In Mobius, you got to put the plus sign in between to enter it. This might be one that you do go to the lesson and look at because it is more complicated. The homework problems you're having trouble with, spend more time on, go to the learning lessons, but the ones you look at and you're like, I got it, you could probably skip the learning lesson. The next 3 problems are 3 problems that are all similar to a problem you have in your homework that also appears on the quiz, and someone I taught you about in class where people have a hard time with it because it's just worded a little weird. This says you have 4/5 of a cake left over. You're going to send 1/3 of the leftovers to a friend. How much do you have left? I'm going to show you 2 ways to do this. So we're going to start with, we have 4/5 of a cake. We're giving 1/3 of it away. So let's look at what that looks like. 4 times 1 is 4. 3 times 5 is 15. We gave this away. So we want to say, what do we have left? So we had 4 over 5, and we gave 4 over 15 away. So to subtract, I need a common denominator, which this time would be 15. So this says 3 times 4 is 12 over 15. Then I have 4 over 15. 12 minus 4 is 8 over 15. So this is what I have left. Another thing, and another way I think to do it, is this. So let's say if I give 1/3 away, how much do I keep? Well, 1 minus 1/3 is 2/3. So this is what I get to keep, and I like this approach better. So I had 4/5, and I'm keeping 2/3 of it. 4 times 2 is 8. 3 times 5 is 15. I got the same thing, but it was a lot shorter. So I like this strategy of thinking about, instead of doing 2 things of what did I give away and subtract, just multiply. I think you'll do better. So I'm going to show you the other 2 with that strategy. So this says you have 2/18 of a quiche left over from lunch. You send 3 over 15 of the leftover quiche home with your brother. How much of the quiche do you have left in the dish? Hopefully this was a really big quiche, because if not, this doesn't make sense. So let's concentrate on this 3 over 15 that we gave away. So we say, what do we have left? Well, when you're looking at what you have left, when you do 1 minus 3 over 15, it's 15 over 15 minus 3 over 15, which is, that's 15, sorry, this is 12 over 15. This is how much you have left, but it's 12/15 of 2/18. So I have 2 over 18 times 12 over 15. 2 times 12 is 24. 18 times 15 is 270. So I'm going to try to reduce that. Like they're both even, so let's divide by 2. 2 goes into 24, I get 12. 2 goes into 270, and I get 135. So I can't divide by 2 anymore. So I'm like, well, could I divide by 3? So 12 divided by 3, I get 4. 135 divided by 3, I get 45. There I'm going to stop. 4 is even, 45 is odd. There's nothing I can do that will divide both of them, so I'm going to stop at 4 over 45. You have 8/17 of a pie left over from a party. You send 9 over 11 of the leftover pie with your friend. How much of the pie do you have left? So start with the 9 over 11. This is what I'm going to give away. So I have to say, what am I going to keep? So I do 1 minus 9 over 11. This will be my keep. Remember where I say 1 is 11 over 11. So whatever this number is, that's how I write my new fraction, which is 2 over 11. And maybe this is a number you can do quickly in your head. You're like, oh, I gave away 9. It means I kept 2. You're just subtracting from 11. So I'm keeping 2 over 11 of 8 over 17. 2 times 8 is 16. 11 times 17 is 187. I cannot reduce that. Like, that is where I have to leave it. Remember, you could go to Desmos, put it in to see if you can reduce it that way. There are other ways to reduce. I'm trying to keep it simple because I know it was a lot this week, but I'm hoping these 3 examples kind of help you out with how to do that word problem, because I'm pretty sure it's going to show up in your homework and on your quiz. So good luck. I know it's a busy week. Let me know if you have any questions.